Hello everyone. Now we're going to talk about Bertrand Duopoly or Bertrand competition. And in this simplest case of this model, there are two firms. If you like, you can call them firm 1 and 2. And each firm selects price, PI, which is in between 0 and infinity, all right? I mean, they can't choose negative price, they can't choose price infinity, so they're gonna choose price for their good. We assume that both firms produce exactly the same good, but they're not able to, they're not choosing their quantity, they're choosing their price. The sort of the difference between Cournot and Bertrand may be, in the Bertrand case, the quantity selection is easier than the price selection. For example, think of a software developer. Once you sort of made the invention, once you develop the software, the producing, for example, I don't know, Word, Excel, whatever. So producing, I don't know, 5 or 10 units of output is not a big deal. It's just basically you're copying the same software, same program on a different CD and then sell the CD. Well, but recently you don't even have to write the softwares or the programs on CD. Everything is downloadable from internet. You see what I mean? So producing is not a big deal, but sort of changing the price is a big deal. So therefore, you choose your price as your strategy, and then depending on the market conditions, meaning depending on the market demand, you determine how much to produce, okay? Obviously, we are going to make a bunch of other simplifications assumption, and the assumptions we're going to make is the following. So let's suppose the inverse demand function is equal to, let's make it even simpler. I'm not going to talk about inverse demand function, but there's a group of consumers who buy from the lowest priced seller. All right, so don't forget there are two firms or two sellers in this market, and the consumers are going to buy from the seller. And remember, both firms are producing exactly the same good, and so the consumers buy the good from the lowest priced seller. Again, so there are a lot of simplification assumptions underneath this assumption. One of them is that the consumers do not have any search cost, which is in fact very important, right? But normally, lately at least, in the age of online shopping, search cost is actually very, very small. For example, when you go on Amazon or eBay and search for an item, what you see is exactly the same item, right? Textbook or whatever, sort of a brand new textbook or brand new item, but they're different sellers, they're different suppliers. Although they all sell exactly the same thing, sometimes you see that some of the sellers are charging slightly lower price than the others. And so normally what you do, you go and buy the good from the lowest priced seller. Obviously in Amazon or eBay, there's also the idea of reputation, right? Maybe the seller is not going to send you the package, or maybe the quality of the item is not as good. They advertise. So for that reason, actually the Amazon or eBay sort of distinguish the sellers, differentiate the sellers by posting their reputations, sort of trustworthiness. But let's ignore all that. Let's suppose the trustworthiness or the reputation of the sellers are also the same. So the firms are identical, exactly the same in all respects. And the only thing is that they can do is, choosing their prices. Obviously, this is a very simplistic environment. Okay, well, that's it. Whoever charges the lowest price will get all the customers. Good. What is the demand? Well, let's suppose demand is equal to PI equals A minus BQ. All right, so Q is the total output. A and B are some positive real numbers. So not PI. P is the market price. So market price. Very good. Well, so here is how maybe we should be careful about this. We should write down the profit function. Profit function of firm I. There are two firms, remember? So I'm going to write it pi I. So it's equal to, it's a step function, and you'll see why. Well, here what matters is whether pi is less than or more than pj, or maybe equal to. All right, so if pi is less than pj, what does that mean? That means firm I is the firm that is selling at a lower price. So that means he's going to get all the customers. Firm J is going to get no customers. In that case, the profit is going to be what? Revenue minus cost. So what is revenue? PI, the price, times quantity. The quantity is given here, right? Minus the marginal cost. All right, so let's assume marginal cost of producing this output is C for both firms. You may ask why we do not assume different C's. You'll see why. Because this is simpler. Different C is a sort of a complicated example. So here, therefore, the marginal cost times quantity. So C times Q. All right? So this is what the profit function will be. All right. By the way, I can write this Q as a function of P, all right? Which I will. So don't forget the Q is equal to PI, A minus P divided by B, all right? So therefore, instead of writing this profit function as a function of Q, what I can write it as PI times Q, which is A minus PI divided by B, minus C times PI. I'm sorry, Q, which is A minus PI divided by B. All right, so that means the profit function is going to be PI minus C times the quantity, which is A minus PI divided by B. All right, well, what if the price of firm I is higher than price of firm J? Well, in this case, the profit is zero. The profit of firm I is zero because it's the high-priced firm, and so everybody is going to buy this product from the other firm, firm J, and so the firm I is going to sell only zero product, and hence zero net profit. Remember, there's no fixed cost. And finally, when the price of firm I and firm J are equal, what's going to happen? Well, without loss of generality, we can assume that half of the customers are going to buy the good from firm I, half of the customers are going to buy the good from firm J. So that means the profit is going to be this divided by 2. So basically, PI minus C divided by 2 times A minus, PI divided by B. All right, so this is the profit function of firm I. It's a bit more complicated than the Cournot case. All right, so the question is, what is the Nash equilibrium of this game? All right, well, it is in fact simpler. Why is that so? Well, you can sort of make finding a best response is a fine job. I mean, you can definitely do that. How so? You can just take the derivative of this guy, set it equal to 0, etc., etc. I mean, this approach is not wrong, but there's an easier way to find the Nash equilibrium of this game. And let me give you the solution. In this game, in the Bertrand competition, the unique Nash equilibrium is such that firm 1's price equals to firm 2's price, which is equal to the marginal cost C. And hence, the profit of firm 1 equals to profit of firm 2, which is equal to 0. Okay? We did not calculate the profit of the Cournot firms in the Nash equilibrium outcome, but the Cournot firms are going to make positive profits. However, the Bertrand firms are going to make zero profits. All right, well, the question is, how do we show that? Well, again, this is a guess and verify approach. And I think it teaches us more than the other approaches that you may follow. So here is one way. Is P1 equals P2 equals C a Nash equilibrium? All right, that's easier to verify. Well, so P1 equals C, P2 equals C. Is this a Nash equilibrium? Question is this regret-free? I mean, is firm 1 best responding firm 2? And vice versa, is firm 2 best responding firm 1? The answer is yes. Let's look at firm 1. Is firm 1 best responding firm 2? Well, the firm 2 is choosing the price equals marginal cost. So we know from our intermediate micro that whenever a firm choosing its price to its marginal cost, right, price equals marginal cost. So therefore, the profit is zero. All right, so that part is obvious, I think. All right. The question is, as firm 1, can I charge a price lower than C to get the customers? Of course you can. So if I charge price lower than C, what's going to happen? My opponent is charging C, but I'm going to charge a price lower than C. So I'm going to get all customers. But the problem is, because PI is less than C, it's going to be a negative profit, meaning I am serving the entire market, but I'm making loss. So therefore, P1 equals C is better strategy than charging price less than C. So P1 less than C is worse than P1 equals C. Very good. But does that mean that P1 equals C is the best response? No, maybe P1 greater than C is better than P1 equals C. Is it? Let's see. When firm 1 charges price greater than C, what's going to happen? So remember, Pj is equal to C, and now I'm going to charge price higher than C. In this case, I will basically serve to no customers, and hence my profit will still be zero. Well, what does that mean? That means P1 greater than C is no better than P1 equals C. Therefore, P1 equals C is a best response, is the best response, in fact, best response to P2 equals C. All right? So, firm 1 is best responding its opponent. And by exactly the symmetric arguments, firm 2 is also best responding firm 1. Hence, this is a Nash equilibrium. All right? So that part is easy. The hard part is maybe, is there any other Nash equilibrium? All right? Okay, so think of this environment where obviously we know that charging a price lower than C can never be part of Nash equilibrium, right? Because, you know, a firm who is charging less than C, one of the firms will be serving the entire market or half of the market, but it's going to make loss. So therefore, if I have a Nash equilibrium other than marginal cost pricing, it should be something like P1, P2, where P1 and P2 are greater than or equal to C, and one of them, PI, is greater than C. I mean, one of them for I equal 1, 2. Okay, for some I. All right, so the question is, can we have a Nash equilibrium of this form? Well, first, maybe observations. If P1 different than P2, then no Nash equilibrium. Why is that so? Well, I think that's kind of obvious. So let's suppose P1 is less than P2. All right? Symmetric arguments work if P1 is greater than P2. All right? So for that reason, I'm going to ignore these symmetric arguments. So let's suppose price of firm 1 is less than price of firm 2. Which is obviously, I mean, one of them is greater than or equal to C, right? So can this be a Nash equilibrium? Well, look at firm 2. What's going to be the firm 2's profit under P1 less than P2 scenario? Because firm 1 is the lowest priced firm, all the customers are going to go to firm 1, and so firm 2 is going to sell no product, and hence its profit will be 0. Clear? Good. However, instead of charging P2, is this regret-free? No. Instead of charging P2, if firm 2 was charging P2 prime, let's call it, exactly equal to P1, so the same price with firm 1, what would be the case? Well, it would be then that the firm 1 is charging exactly the same, firm 2 is charging exactly the same price of firm 1, and hence they would split the profit, which is positive, as long as P1 is greater than 0. All right? Once again, if firm 2 decreases its price to the firm 1's level, well then firm 1 and firm 2 would share the market equally, and firm 2 therefore would get positive profit if P1 is greater than 0. But what if P1 is exactly equal to C? Because if I reduce, as a firm 2, if I reduce my price all the way to marginal cost, my profit will be 0 anyway, right? Very good. Well, in this case, so let's say P1 is equal to C, but P2 is greater than P1. Can this be Nash equilibrium? No. Why not? Well, this time, firm 1 has incentive to deviate. So it's going to regret from P1. Why is that? Well, look, by charging price P1, I'm already getting all the customers, and I am getting 0 profit because I'm charging P1 equals marginal cost. But you know what? There is room between the marginal cost and P2. All right. And then, for example, P2 is $1 and the marginal cost is $0. So you know what? Why don't I charge, for example, 99 cents? Something higher than marginal cost, but slightly less than P2. I will still get all the customers, but because I am charging a price higher than marginal cost, I'm going to get positive profit. So therefore, in this case, firm 1 has incentive to deviate. So in this case, if P1 is strictly greater than C, we just show that firm 2 will deviate, and hence firm 2 will deviate, or it's going to regret his choice. And so no Nash equilibrium, because P2 will never be a best response. In this case, firm 1 will deviate, and therefore P1 is not a best response to P2, so there's no Nash equilibrium. So that means we cannot have a Nash equilibrium where one of the firm's price is lower than the price of the other firm. So if there's a Nash equilibrium, price of firm 1 has to be equal to price of firm 2. And then the final step. Let's clean this part. Is there any Nash equilibrium where P1 equals P2, but it's greater than C, right? Because we already concluded P1 equals P2, which is equal to C, is a Nash equilibrium. I'm looking for another Nash equilibrium different than this one. So here, is there any Nash equilibrium where price of firm 1 equals to price of firm 2, which is strictly greater than C? And the answer is going to be no. Why is that so? Well, here, if this is the case, firm 1 or firm 2 has incentive to deviate. Why? Because they're sharing the market, because they're charging the same price. If firm 1, however, so this is like they're charging $1, but the marginal cost is $0. Okay, so the question is there any Nash equilibrium where P1 equals P2, which is greater than C? Well, I don't want P1 equals P2 to be exactly equal to C, because I already discussed that this is a Nash equilibrium. I'm looking for a Nash equilibrium other than this one. So, but I just argued that if there's a Nash equilibrium, then the price of firm 1 and firm 2 must be equal. So they're equal, but strictly greater than C. Well, can this be a Nash equilibrium? No. Why is not? Well, because in this case, firm 1 and firm 2 are charging the same price, and so they're sharing the market demand, all right? That means this is the profit that they're getting. However, instead of doing this, if firm 1, for example, charges slightly lower price, slightly, let's say 1 cent lower, what's going to happen? Well, you're going to serve the entire market, all right? And the PI, the new price, is not going to be too different than the other price, right? So this is, for example, $1, and the marginal cost is 0, let's suppose. So instead of charging $1, why don't you charge 99 cents, for example? So 1 cent is not going to make huge difference in terms of revenue, but serving the entire market rather than half of the market is going to make much bigger difference. So you can actually formally show this for appropriate, for most demand curves, this is actually the case. So therefore, whenever P1 and P2 are equal, but they're higher than the marginal cost, each firm has incentive to price undercut its opponent. Price undercut. All right. So basically, this is a price war. All right. So you know that your opponent is charging a price higher than the marginal cost. You're also charging a price higher than marginal cost. Instead of sharing the market, I price undercut my opponent. So I become the seller who serves the entire market. But then once again, that means P1 is going to be less than P2. Obviously, firm 2 also has the similar incentives to deviate. But, well, can this be equilibrium? Remember, we said no, because firm 2 also has the incentive to charge price instead of leaving it like this. Firm 2 has incentive to price undercut P1, meaning P1 minus epsilon. All right? So, firm 2 will price undercut, and then firm 1 will price undercut. So you see the logic. They will price undercut each other until they both hit the marginal cost. And from there on, they cannot price undercut each other because the marginal cost pricing is actually zero profit. If you try to price undercut your opponent, you're going to get negative profit. So you're going to stop. The firms are going to stop there. Okay? So, therefore, the conclusion is that in the Bertrand model, price of firm 1 equals price of firm 2, which is equal to the marginal cost of these firms, is the only Nash equilibrium. Unlike the Cournot, the firms are going to get zero profits. And this is how we analyze the Bertrand competition.